Okay, so 712, do I need to know every measurement? So what that's essentially saying is this. For triangle congruence, we already figured out that side angle, side angle, side angle worked. We know that that proves triangle congruence. If all the sides and all the angles are the same, that means that the angles have to be the same shape and the same size. But we're going to start trying to get some shortcuts and seeing if things like, what if we know an angle, a side, and the side that connects two angles? Or what if we know a side, and an angle that doesn't connect them? Will this be enough to prove triangle congruence? Will this be enough to prove triangle congruence? So that's what a lot of Chapter 7 is about, is going through and exploring these things one at a time to figuring out how much we need to know and see if there's any shortcuts that we can figure out to determine triangle congruence. So 712 part 1 has us do a couple problems, and you'll see that this got a little bit cut off here, so I sort of filled in the rest of what was in the book. It says, Jovan and Mia are on the same team, but Jovan missed class yesterday. Mia explained, if two triangles have all the same corresponding angle measures and all the same corresponding side lengths, then the triangles are congruent, but never trust the way figures look in a diagram. Jovan and Mia need your help. They cannot decide if the two triangles are congruent. Well, again, if we're going to use the the Pythagorean theorem to figure out the side lengths, and the triangle angle sum theorem to figure out the angles. So if 21 squared, this would have to be 21, this would have to be 28, and this would have to be 28 for these things to have all the same sides, right? So we're going to say, all right, is 21 squared plus 28 squared equal to 35 squared? Because if it is, then we know that the sides are the same. So they are. So we know that this has to be 28 and this has to be 20. Well, this is 28 and this is 35. Well, this has to be 1 if this is a right triangle, 21. And we know that this is 21 and we know that this is 35. Well, this has to be 28 if this is going to be a right triangle. So the Pythagorean theorem tells us those. The other thing is these angles have to add up to 180 degrees. So again, this would have to be 36.87 right here. And this would have to be 53.13 if these triangles were congruent. But in order for that to be the case, 90 plus 36.87 plus 53.13 would have to equal 180. So let's see if it does. Because if it does, then we could say, yeah, these triangles are congruent. But if this doesn't equal 180, then we know we have a problem and that these triangles won't be congruent. So again, we're hoping to see this equals 180. And it does. So yeah, we can say, all right, well then, if this is 90 and this is 53.13, this must be 36.87. And if this is 90 and this is 36.87, then this must be 53.13. Hey, look, all the sides are the same length and all the angles are the same. So we have side angle, side angle, side angle congruence. And we know that that's true. Jovan says, if the triangles are congruent, there must be a rigid transformation that maps one onto the other. Even though these two triangles have all the same angle measurements and side lengths, they can't be congruent. There's no way to make the corresponding sides map onto each other with rigid transformations. I would say he's incorrect. I should be able to rotate this thing down and then reflect it and then translate it, and then it will. So yeah, I would say he's just missing that you can actually do it. Mia spoke up, hey, I just thought of something. If two segments have equal length, they must be congruent. There's always a sequence a sequence of rigid transformations that maps one segment on the other. For example, MN is congruent to QS. Is she right? Well, if you remember back to 711, we said we can make triangle congruent statements. So let's say triangle MNP would be congruent to what triangle? Well, M is across from 35 and Q is across from 35. N is across from 21, so we would take, and this is a little bit cut off here, this actually ends up being letter S. I have a note from the book. So N is across from 21 and S is across from 21. And then P is across from 28 and R is across from 28. So what she's saying is MN and QS go together. I agree with her. Yeah, our triangle congruent statement says that those sides match up. They're in the first two spots. So yes, she's right. Likewise, two angles that have the same measure are always congruent. For example, N and S are the same, which is true. We already have those matching up. Write as many triangle congruent statements as you can from these triangles. Well, here's one of them. And again, I said there's 6 ways to write these things. So here's one of them. The other thing, I could have MPN is congruent to triangle QPS. That would be the second way. Then I could say triangle PMN is congruent to triangle is there 2 P's here? What am I? MNP. Oh, this is QSR. This is an R. I'm sorry. So these are R's. They're not P's. My mistake. Jeez Louise, I'm on fire making a mistake these days. So PMN is RQS. So we know that PNM is congruent to triangle RSQ. And then finally, we've already done M in the first 2 slots and P in the first 2 slots. So now we will say N in the first 2 slots. So we'll say NMP is congruent to SQR. And then finally, triangle NPM is congruent to triangle SRQ. I believe. So hopefully I didn't screw that up. Let me pause the video and go through these. There's 6 of them. I screwed up the P and the R already, so let me make sure all the rest are okay. That these appear to be the 6 ways of writing it. It looks pretty good. Again, I apologize for the P and the R. I'll make another note on that. All right, so at that, we will close this and keep going. Oh geez, we got cut off again here. That's frustrating. Okay, so 7:13, it says, how much is enough? Jovan is tired of determining all the angle measures and side lengths to determine if 2 triangles are congruent. I don't think I need to find all those measurements. There must be an easier way, he thinks. What if all I know is that all the angles are congruent? Is that enough that the triangles are congruent? So he's saying, again, we're dealing with this. We know if we have all the sides and all the angles that the triangles are congruent. He's saying, what if I just know all the angles are the same? Is that going to be enough to prove congruence? So it says, start by making a prediction. Do you think that 2 triangles must be congruent if all 3 pairs of corresponding angles are congruent? So if you think that is true, then great. You can say that. If you don't think it's true, then you can guess that. It says experiment with Jovan's idea. To do this, use the E-tool. I'm not really good at using these E-tools, so I'm just going to go something like this. What if I know that I have a right triangle, and then I do this, and I make these lines parallel? Okay, if these lines are parallel, well, first of all, obviously these angles are the same because they would be the same angle. Well, these angles would also be the same because these would be corresponding, right? If these lines are parallel, these would be corresponding angles, and these would be corresponding angles. So I know all these angles are the same, right? I have angle, angle, angle. Well, are they the same size? Of course they're not the same size. So we know that angle, angle, angle doesn't work. That does not mean congruent. Although it is true for similarity, which you'll learn in integrated 2. But as far as congruence, they are not congruent. Angle, angle, angle is not enough. So is this a good way to do it? We'd say no. So 7:14, Jovan is not ready to give up. Okay, in a pair of triangles, what if we know that all 3 pairs of corresponding angles are congruent and also one pair of corresponding sides is congruent? Is that enough information to determine the 2? So we're going to get something like, we know all the angles are the same. And what about if all the sides are the same? I'm sorry, one of the sides. So again, we have something else where all the angles are the same. That doesn't look good at all. So we're going to say, okay, geez, this is terrible. So here's what I would say. I would say he is correct. If I just take this side and make it a length of sixth, so I go here and make it the same length of sixth, if you imagine that it has the exact same length, okay? And then I do the same angle here. So I say, all right, well, I'm just going to go something in this direction so I know that it's 120 degrees. See, this is going real well here. I'm going to pause for a second. All right, sorry about that. My family was leaving, so I had to say goodbye. So anyway, we had the side of sixth, and then I said, all right, well, let's pretend I make this angle 120 degrees, and let's pretend this is a straight line as well. Anyway, if I go over here and I take this 30 degree, and I say, all right, I'm going to make another line, and I'm going to go across here, and this is going to be 30 degrees, right? I'm determining that with like a protractor. Well, does that mean that these triangles are the same? Well, yeah, it doesn't have any other choice but to be 30 degrees here as well. Just if I make this angle the same and this angle the same, and I have this side the same, right? Because of what we know about triangles, this one has to be the same as well. And then you'll notice, yeah, it's going to be the same size triangle. So it turns out the angle side is a way to make, it's a shortcut. If we know the three angles on one of the sides, we now no longer need to know side angle, side angle, side angle. We have learned one shortcut. One of those, but it's got to be a corresponding side. You see how this 6 is across from a 30-degree angle? The 6 has to be across from a 30-degree angle. For instance, what I'm saying is if we did something like this, and we said this is 120 degrees, and this is 30, and this is 30, and the 6 goes here, across from the 120, it would no longer be congruent. It has to be a corresponding side. So that's a really important deal there. So that is 712 part 1.